Anybody don't get? Hello, you are welcome to another special class again on Circle Theorems. Last night, I don't know how many of you were here last night, we started tangent radius theorem. If you were here, type 1 in the comments. If you were in yesterday's class, type 1 in the comments. We are starting now. In fact, we have started already. If you were here yesterday, type 1 in the comments. But if not, it's fine. We talked about tangent radius theorem. And from what we talked about yesterday about tangent radius theorem, we said that the angle between a tangent. Now you might be asking, what is a tangent? Let me put T here and A here. This line TA is a tangent. From the point, a tangent is a line that touches a circle at one point. Now, if at the point of contact, a tangent meets with a radius, this is a radius. A radius is a line drawn from the center. From the center, hope you can hear me. From the center, this is a radius, okay? And this is a tangent. So the angle formed is 90 degrees. 90 degrees. That's the angle formed. Okay, so please, before we continue, please I want you to like this live now, please. Kindly like the live so other people will join us. Kindly like the live, and you need your support. There's no like already, and we have 15 here. Please like the live. Let's continue. So I did say that the angle between, please don't forget this theorem. The angle between a tangent and a radius is 90 degrees. So if you want to solve this question, they say you should find angle X. How are you going to do it? You are supposed to be able to get this angle. See, you must be able to get this angle. This angle. If you can get that angle, you can easily get angle X. Easy. All I have to do is to subtract this angle from 90 degrees. Because see, this angle here is 90 degrees. All right. Once I'm able to get this, let's call this angle A. Or I have to label this now. I'm going to call this is A. Let's call this B. All right. This is O. So if I can get OTB, that's this angle here, I can easily get angle X. The question is, how can I get angle OTB? This angle. See where my finger is touching here. That's where my finger is touching. How can I get that angle? If you know what I can do, please, I need you to tell me how to get this angle. Or let me ask another question. What triangle is this? If you know it, type it in the comment. What triangle is this? Okay, am I saying math? Yes, Karusha. Yes, this is math. We are doing math here. So this is an isosceles triangle. How do I know? Because it is bounded by two radii. Let me show you. See, this and this. This line OB and line OT, they are two radii. So we can simply say that OB is equal to OT. From here to here, OT. And you say radii. Then you say, therefore, triangle OTB is isosceles because you have two radii. If a triangle is bounded by two radii, see, if you have a triangle like this, and this one is a radius, this is another radius, it is clearly an isosceles triangle. And if that's the case, the base angles are equal. All right, so if this is 40, for instance, this has to be 40 degrees as well. So that's what is going to happen here now. Now, if you know how to get, let's get this angle, let's get BOT. Let's get angle BOT. Angle BOT. If I can get this angle, let me use this color. If I can get this angle here, I can easily get the base angles because the base angles of an isosceles triangle are equal. So let's get this angle. Who can tell us how can I get this angle? You can use 278 to get this angle. Type in the comment and tell me how I'm going to get this angle. This angle BOT. Angle BOT. Not, this is the reflex angle, but this BOT is not reflex. How can I get this angle? Who can tell me? Oh, thank you. 360 minus 278. Beautiful. So I'm going to say angle BOT is equal to 360 degrees minus 278 because the sum of angles at a point is 360 degrees. So minus what? 278 degrees. Please, you must always write the reason. I can say angles at a point. Very important, you always give the reason, all right? So this is equal to what now? What's 360 minus 278? That's what? 22, 80, what now? 82, right? Who is giving me the answer? That's what? 82, right? 82 degrees. Hope that's correct. Beautiful. So we have gotten this angle now. Now, how can I get the base angles? See, the base angles. This one here and this one. I told you that the base angles are equal. Now that we know this angle of this triangle, we can easily get the base angles. All you have to do, subtract this angle from 180, then divide it into 2. Let me say it again. Because this angle here is 82 degrees. Let me bring out the triangle. This is the triangle, right? This is what? 82. And these sides are equal. You can get the base angles. All you have to do, subtract 82 from 180 divided by 2. Without wasting time, I'm going to say that OTB, angle OTB is equal to what now? Is equal to 180 degrees minus what? 82 degrees. But that's not all. You must divide it by 2 because you are splitting it into 2 base angles that are equal. Divided by 2. Please always give the reason. In bracket, I'm going to write base angles of an isosceles triangle. You can use this short code. You see this is angles, this is triangle, this is isosceles. All right. Now, who can tell me now what is 180 minus 82? That's what, is that not 98? Yes, thank you. So 98 degrees, then you divide it by 2 because we need to split it into 2 base angles, which is what? Who can tell me what's that now? I need you to oh, thank you for the likes. Divided by 2, exactly 49 degrees. Thank you, American born. Thank you, American born, 49 degrees. Now, but that's not all because they say we should find x. Remember, I told you that the angle between a radius and a tangent is 90 degrees. So can you see now that we can easily get x now? Who can tell me what will be x now? X will be equal to what? Hope you can see this. I don't know which shadow I should use. X will be equal to what? Can you see the board from here? Okay, maybe you can. X is equal to what? 90 degrees minus what? This angle here, OTB, is 49. This is already 49. So for you to get x, you have to subtract 49 from 90 degrees. So I'm going to say 49 minus 90 minus 49 degrees. In bracket, I'm going to write that what? radius tangent theorem. Radius tangent. You can just say radius tangent. That's okay too. So what is 90 minus 49? That's what? 0.41. So x is equal to 41 degrees. That's all. That is the value of x. If you understood what I did, please type yes in the comments. If this is clear to you, type yes in the comments so we can move on. Type yes in the comments so we can move on. Oh wow, I have 84 of you in this live. Thank you so much for your support. Thank you for turning up. Thank you so much. God bless all of you. Please, let's like the live. Just tap the like button there and let's get this across to many people. So if you are taking a screenshot, please do so. I want to rub this off, so we'll go to another example. We're going to do one more example on tangent radius theorem, and then we'll now go to alternate segment. You are lost. Okay. Maybe because you just joined us. Maybe because you just joined us. But don't worry, you can go and watch my previous video on tangent radius theorem. You can go to my live playlist and you will see lesson 1, you will see lesson 2. I'm addressing Garth Simpson now. You will see lesson 1, you see lesson 2 there, okay? Watch it, then you'll be able to understand everything that we're doing now. Okay, let's move on to, we'll do one more example on this theorem, and then the next one will be alternate segment theorem. I got so much loaded for you today. So, make sure you like the like. Please, let's hit the like button. Let's tap on the like button so we can get this live across to many people. Thank you all for your support. I'm so grateful. Now, let's keep going. Another, yes, another example. Where are we? Okay, that's here. I have a circle, right? And you might have to try this by yourself if you can. I'll give you like one or 2 minutes to try this by yourself. Then we'll now move on to alternate segment theorem. Center O. This angle is 3x. Okay. I have a tangent. Yeah. And this is 63 degrees. This angle is 63 degrees. Let me highlight it well for you. Yeah, that's 63 degrees, okay? And then it says, I'm going to label this. This is, let me use this color. This is T, A, B, C, center. Okay. Let me give you 1 minute to attempt this question. So you have to find the value of x. Let me write it here. Find x. Find the value of x. Let me give you, if you can do it, please just type 1. If you are attempting the question, type 1 in the comments. If you are attempting the question, type 1 in the comments. Thank you for the like. Those of you who are liking this. If you are attempting the question already, type 1. If you want me to do it, type 2. If you want me to do it, type 2. If you are attempting it, type 1. Somebody has gotten the answer. Wow, okay. Let's wait for other people. Okay. Okay, so Sammy wants me to do it. Okay, Ak wants me to do it. Okay, I think I'll just do it because many people actually would struggle with it. So don't worry, it's very easy. I told you before that what? That the angle between a tangent and a radius is what? 90 degrees. Somebody tell me now, somebody talk to me. If this angle here is 63 degrees, who wants to help us out now? What will be this angle, this base angle? If you know it, say it in the comment. If this is 63 degrees, who wants to help us out? What will be this angle? Who can tell me? What's going to be the base angle of this triangle? I'm doing it already, ketone. I'm doing it already. Sir, can I see the answer? Well, x is equal to 42 degrees. Okay. Oh, okay. If you say so, that's okay. 27 degrees. Oh, thank you, Kadasami. How did you get that 27 degrees? Because the angle between a radius, this is a radius, see, from it is a radius, okay? Between a radius and a tangent is what? 90 degrees. Can you see? It is 90 degrees. So if that's the case, they already told us that this angle here is 63 degrees. So to get the base angle of the isosceles triangle, you will simply do 90 degrees minus 63 degrees. So let me just say that angle OTB is equal to 90 degrees minus what? 63 degrees. We are subtracting this 63 degrees from 90 degrees. In bracket, I'm going to say radius tangent theorem, okay? Yeah. And for the person that said the answer is what? 27 degrees, you are correct. So this angle is 27. Not just this one too, even OBT. So angle OBT is also what? 27. See, this angle here is also 27 degrees. What's the reason for that? Base angles of isosceles triangles. Yes, this angle is also what? 27 degrees, because they are the base angles of the isosceles triangle. Now I want to do something. I want to bring out this triangle. This is how the triangle looks like. What am I doing? It goes like this, all right, and like this. So we have this. This one is 3x, okay? This one is 27, and this is 27. See, they are both because they are the base angles. Now, who can tell me? Please just type in the comment. What am I going to use to get x now? Type in the comment. How can I get x? Just type in the comment. What should I do? Who can tell me? I am going to add all the angles, all right, and equate the sum to what? 180 degrees. Why? Because when you add all the angles in a triangle, you can equate that sum to 180 degrees. Beautiful, beautiful, interesting. But what proof is there that the square you have created is really a square? I didn't get, there's no square here. There's no square. So I'm going to say that 3x plus 27 degrees plus 27 degrees, all is equal to what? 180 degrees. Always write this in bracket, sum of angles in a triangle, all right? So if you add these two, you get what? 54 degrees. 3x plus 54 is equal to 180 degrees. See what I'm doing now? Then move 54 to the right hand side, or you can subtract 54 from both sides. So you have that 3x is equal to 180 degrees minus 54 degrees. And when you take the difference, what would that be? Is that not 126 degrees? 120, is that 126? Okay, and then you divide both sides by 3. You divide both sides by 3. So x is equal to 126 degrees divided by 3, which is 42 degrees. Beautiful. Those are set 42. Well done. Arc, well done. Kadan Sami, well done. The answer is 42 degrees. So we are through with problems involving tangent radius theorem. It's now time to move to alternate segment theorem. Another very interesting circle theorem. If you want me to move on, type yes in the comment. If you want me to move on, type yes in the comment. Thank you for the like. If some of you have liked this live already, I'm so grateful. If you haven't liked the live, please let's hit on the like button so we get other people to join us right here. Thank you all. Thank you all. Thank you. Thank you. Oh, yes. Thank you. Thank you. So it's now time to move on to the alternate segment theorem. Take a screenshot at the count of 5. 1, 2, 3, 4, and 5. Okay. So it's now time for what? Alternate segment theorem. So we're doing alternate segment theorem. Now, this is one circle theorem that used to pose a lot of challenge to students, but I'm here to help you understand it better. I am here to help you understand this theorem better. So I'm going to draw, okay, this is the theorem. It states that the angle formed between a chord and a tangent at the point of contact is equal to the angle subtended. Don't worry, I will explain this by the chord in the alternate segment. I am going to explain this. Don't worry, I'm going to explain this very well for you. After this video, you will never have any trouble, any reason not to be able to answer a question involving alternate segment theorem. See, I want to underline something. What many people do not get to see. See, they said subtended by the chord. When you say subtended, it means that the chord is responsible for subtending, for forming that angle. You see, this subtended by the chord is very important. Now let me draw a circle and then show you something. See, I'm going to draw a circle. All right. And this is the center. We don't even need that, do we? I'm going to draw a tangent. You know, I told you a tangent touches a circle at one point. That's a tangent, okay? Now, from this tangent, I am going to draw a chord and then another chord. Then join it like this. Please take note of something. We have 3 chords in this circle. All right, we have 3 chords here. But I am interested in, let me say I'm interested in this chord. Let me call this AB. I'm interested in chord AB because that is where the angle, we are going to put the angle. So let's put our angle here. All right? Let's put the angle here. And let's call the angle X. All right. So what does this alternate segment tell us? If you see, the angle formed between a chord, AB is a chord. A chord is a straight line that joins two ends or 2 parts or 2 points on the circumference. So an angle formed between a chord, this is a chord, and the tangent. This is, let me use this color for tangent. See, this is a tangent. It touches the circle at one point, okay? The angle formed, see, this is the chord, this is the tangent, and this is the chord and tangent. This angle here is equal to the angle in the alternate segment. But see this, subtended by the chord. Look at the chord we are talking about. It will surprise you to know that this chord subtends this angle. See, this chord subtends this angle from here, from the end point of the chord. You see this? It goes like this. And this one goes like this. Can you now see that this chord subtends this angle? Right? Such a great lesson. I hope you grow. Thank you so much. Thank you so much, Mana. So, see, this is a chord. This chord, excuse me, subtends this angle here. Look at this. Are you seeing it now? They say in the alternate segment. What's a segment? A segment is an area bounded by a chord and what? And an arc. So if you call this a segment, the alternate segment is the one on the other side. All right? This is one segment, a minor segment, but this is what? Another segment. So the angle subtended by this same chord In the alternate, many students used to confuse that. See, this is one segment where the angle is, but in the alternate segment, which is this one here now, you see the way I am demonstrating this. This is not the segment we're interested, but in the alternate segment, this chord forms this angle, subtend this angle. Then you can now conclude by saying that if this is x, whatever this angle is here must also be this angle. That's all. So you call this one x as well. Quickly, let me say it again. Angle formed between a chord, this is the chord, and a tangent, this is the tangent. This is the angle formed between the chord and the tangent. Good. Is equal to the angle subtended, created, formed by what? The chord. Which chord? This chord AB. It's creating this other angle here. In the alternate, this is one segment, this is the alternate segment. All right. The angle formed is equal to the angle between the chord and the tangent. Now, let me show you another thing you can do again. Let me just show you. See, you can easily just do this. From where I've shaded this segment, when you have the angle, you can just draw your arrow like this. Where the arrow is pointed towards, the angle formed is the angle in the alternate segment. If you understand what I have just done, type yes in the comment. Type yes in the comment. I just told you about angle between the alternate segment theorem. If you understand what I've just done, type yes. Thank you so much. Grateful show. Thank you so much. Wow, Daya, thank you so much. Rishi, thanks for your feedback. I'm so grateful. Daya, thank you. You're welcome. Yes. Oh, 137 of you. Beautiful. Please, let's like the live. Let's like the live. Let's like the live. Now, I have just explained. Please, you need to understand. Many students used to confuse this a lot. It used to confuse them. If you have the chord, which angle is the chord subtending at the circumference? See, A to B. You join it here. All right. So this angle formed is equal to the angle between the chord and the tangent. Easy peasy. If you want me to move on, type 1. If you want me to move on, type 1. Thank you, Peter. Thank you, Peter. If you want me to move on, type 1. If you want me to move on, type 1. Yes, thank you, Daya. Okay, grateful show. Thank you. Yes, I will move on now. Thank you. So don't ever confuse this again at all. It's very easy. Tangent, alternate segment theorem. It's very, very easy. This segment here, another segment here. The angle formed by the chord is equal to the angle between the chord and the tangent. Beautiful, beautiful. So we need to look at some examples, some very interesting examples. You will see how easy it will be for you to identify the angle in the alternate segment. It's going to be very easy, very cool. All right, we are ready for more examples. Let's do this. Let's do this. Let's do this. Okay. Here we are. I have a tangent. All right. From here, I have the chord. And the subtended here. This is 65 degrees. This is B. This is A. And this angle is what? 58 degrees. Okay. This is T. Yeah, and this is point C. So we need to find, it said TA is a tangent. All right. And we need to find size BAC. Where is BAC? BAC. That's this angle here. All right. So that's the angle we want to find. What can I use here? Which theorem can I use here? And what can you see? Thank you so much, Peter. Yes, you say what confusing student is identify the opposite angle. Beautiful. That's very, very true. They find it difficult to understand that. Please, let's like the live. We are so many. We are over 100 here. Let's like the live. Thank you so much. So they said TA is the tangent. All right. This is T here. And find the size BAC. That's this angle here. How can I get that? Now, you already have an angle between a chord and a tangent. You see, TA is the tangent. From here to here is the tangent between a chord and a tangent. And I told you that it's easy to identify the angle in the alternate segment. Anytime you see a chord and a tangent, try to locate the angle in the alternate segment. People, beautiful people here, see, this is one segment, all right? It's easy to get the angle in the alternate segment. All you have to do, this chord you see here subtends an angle in the alternate segment. So see, I'm going to trace it here so you see what I'm talking about. From here to here, and from here to here. You see that? This angle is the angle in the alternate segment. So this angle here, let me use just one stroke. This angle is equal to what? 58 degrees. If you agree, type yes. Yes, thank you. Is it 58? Oh, you have got your answer already. So I'm going to say that what? ABC, angle ABC is equal to 58 degrees. Why? Alternate segment. ALT for alternate and then segment. You see now, it's very easy. Once you have been able to shade this segment, just draw an arrow here. You see that? Once you draw the arrow, it takes you to the angle in the alternate segment. So this angle is 58 degrees. That's all. But that's not the angle we are looking for. They say we should find what? Sides BAC. Where is the angle? BAC, this angle here. What do we do now? Easy, because this is a triangle. When you add all the angles in a triangle, you are going to get what? 180 degrees. So I'm going to say that BAC, angle BAC is equal to 180 degrees minus the sum of the two angles, which are what? 58 degrees and what? 65 degrees. Please always write the reason in the bracket. Always do so. I'm going to write in the bracket sum of angles. You can use short code for these angles in a triangle. Okay. So angle BAC now is equal to 180 degrees. All right. Minus what? What is 58 minus 65? 58 minus 65 is what? Is that not 123? Is that right? Thank you so much. So what is this? 180 minus 123 is what? 57. Beautiful. 57 degrees. Wow. If you were here, I would have said you should clap for yourself. Thank you, all of you, for getting it. Yeah, 123. Thank you. Thank you, Daya. Yeah, so the answer is what? 57 degrees. Can't you see how easy it is now for us to be able to identify the angle in the alternate segment? Once you get the angle, see, just shade the segment like this if you like, and draw an arrow. Whatever the arrow is pointing to is the angle in the alternate segment. Don't ever confuse alternate segment theorem again. Never. It's very easy to identify the angle. If you want me to move on, type 1. Just type 1 if you want me to move on. Please, let's like the life. Like the life. Like the life. More like. Thank you so much. Thank you so much. Thank you so much. Well, thank you so much. So let's move on now. We need to do another question involving angle in the alternate segment. Yeah, all of you are so much welcome. Okay, so we have done that. Let's move on. Page 9, 2. Okay. Okay. This is quite an interesting one. Now, I will not be writing, the note here is quite lengthy. I just want to summarize the question, but we're told that PA is a tangent. From here to here, this is a tangent. I don't have to write that because of space. But we also know that AB is equal to DB. It was shaded here. I mean, it was marked equally. So AB is equal to AD. That's for that. And they said angle ACB is equal to 70 degrees, as you can see here. Then we have to calculate angle PAD. Angle PAD. Yes. We have to calculate angle PAD. Where is that? Let's see. You must be able to identify this angle. Very important. PAD, from P to A to D. That's this one here now. Let me use a red ink for this. So this is the angle we're asked to find. This one here. Okay. What do we do? What do we do? I talked about angle in the alternate segment. Same angles in the same segment. I don't know if some of you were here during that time that we had that lesson. Angle in the same segment. If you were here, just type 1. Some people are already getting the answer. Okay, that's interesting. If you're here, type 1 in the comments. Let me just quickly go back to that theorem. Angle in the same segment. It's easy to identify angle in the same segment. As a matter of fact, this angle here is 70 degrees. I'll tell you why. I'll tell you why. Just hold on. This angle is 70 degrees. But before that, let me just write it that angle ADB is equal to 70 degrees. And in brackets, the reason for that is what? Same segment. Or let me write it in full. Angle in the same segment. Angle in the same segment. All right. How do you identify angles in the same segment? How? Let me explain how you can do that. People, watch this now. How do you identify angle in the same segment? It's easy. Look at this. I am here to explain things to you. See, this is how you identify angle in the same segment. See, from here to here. Look at, can you see this line, everybody? You see this line? This line or the chord subtend this angle here. All right? And the same line subtend this other angle. You see what I'm doing? You see that? Can you see? So that is what I will always encourage you to do. It subtend this angle here, and it subtend this angle. So because this chord, is it really a chord? This arc is responsible for subtending this angle and this angle. You can now say that the angles are in the same segment. You will say that the angles are in the same segment. Just 1 minute, please. So see now, see, you have to see, once you are able to get this angle, trace it again. You see, I can trace it from the same end point, from the same point here, this one and this one. This point subtend this angle here. And the same point, you can still trace it again to this other angle. That means that the angle in the same segment, which means angle ADB is equal to 70 degrees. Now that I have got this angle, who can tell me, how can I get angle PAD, this angle here now? How can I do that? How can I get angle PAD? How? I don't know if you can see a tangent and a chord. See, this is a tangent, and this is a chord. What did I tell you about angle in the same, angle in the alternate segment? So, see, this angle, if I shade this segment, All right. To get the angle in the alternate segment, just shade this segment and draw an arrow like this leading to this point. So this angle here, all right, and this angle, they are the same. This angle ABD, this angle ABD is equal to angle PAD. So all I need to get now is to be able to get this. Once I'm able to get this angle, I can get angle PAD. Let me say it again. Once I am able to get this angle, I can get angle PAD because they are equal. But I can easily get this angle here. Easy. See, in case you are not seeing something, there are two strokes here, meaning that triangle, I'm going to say that triangle ABD is what? Isosceles. They are both marked equally. The triangle is what? Isosceles. So that means that the base angles will be what? Equal. I can even say that this angle here, which is what? Angle DAB, I say angle DAB is equal to what? 70 degrees because they are base angles. See, this is the triangle. These are the marks. So the base angles, this angle and this angle, they are the base angles. So angle DAB is equal to 70 degrees. In bracket, you are going to write what? Base angles of an isosceles triangle. This is 70 degrees. Of course, I can get angle what? ABD. So angle ABD, will be equal to what? It's a triangle. Yes. It's a triangle. See, from here to here, it's a triangle. See that? See the triangle? So when you add all the angles in triangle, you should get 180 degrees. So I'm going to say that angle ABD, which is this angle, is equal to what? 180 degrees. Let me use a better mark. 180 degrees minus the sum of the base angles, 70 degrees plus 70 degrees. In brackets, write sum of angles in a triangle. All right. So this is 180 degrees minus 70 plus 70 is what? 140 degrees. If you subtract this, you get what? 40 degrees. That's it. Finally, you can now say that PAD, angle PAD. So I can say that angle PAD. Let me just finish it here. I'll just finish it here. Angle PAD is equal to 40 degrees. Why? Alternate segment. This is the concluding part. I've gotten ABD. I told you that this angle PAD is equal to what? This angle ABD. I know we have different steps, but at the start, I started with what? Angles in the alternate segment. This one and this, all right? Then from there, I was able to get the base angles of the triangle because it's an isosceles triangle. Then from there, I got the third angle using sum of angles in a triangle. Then from there, I was able to realize that the angle we're asked to find, angle PAD, is in the same segment. It's an angle. Using the alternate segment theorem, you will realize that this angle and this other angle in the alternate segment, they are equal. I know it's a lot of step. But if you understand what I just do, please just type yes in the comments. If this is clear to you, type yes. Thank you, Peter. Thank you so much, Peter, for your comments. Thank you so much. Hi, Gamer. You're welcome. Thank you so much. If you want me to move on to the next question, please type yes in the comments. Please type yes. You are all welcome. Good to have all of you here. Good to have you all here. So first thing first, I was able to get what? Angle in the alternate segment. See, I already told you how. If you can trace it from the same point, that's one. Number two, I was able to know that ABD is an isosceles triangle. It was marked, both sides were marked equally. And then I was able to get the base angles. From there, I got the third angle in the triangle. And from there, I used alternate segment theorem to get angle PAD. Thank you, Peter, for grateful show. Thank you. I think we can move on now. We are going to just do one more question. Yeah, please just pardon me. I have to be fast. I need to. Omit. So this one should be much, I think this one should be much easier. This should be much easier. Okay, so I have this. I'm going to try one and you do one by yourself. So you do the last one by yourself. But let me do this with you. Let's like the life. Let's like the life. If you haven't done so already, please like the life. Here we need to find x. This is T, A, B, C. All right. Let's call this M. Or yeah. So find x. Find the size of angle x. Okay. If you can do it, you can start if you can. But let me give you some head start. Let me give you a head start. See, first of all, we have a chord. We have a tangent. Can you see? You should always start from what you know. I know 70 degrees. Start from what you know to what you don't know. All right? I can use this 70 degrees to get this angle. Easy now. I already told you about angle in the same segment. All you have to do, shade this segment for clarity, and then draw your arrow like this. So this angle TCB, angle TCB is equal to what? 70 degrees. Why? Alternate segment. Yes. But even after getting this 70 degrees, is this all we need? No. We still need to get this angle X, which is here. What do I do? Who can tell me the next step? What's the next step? Now that I've gotten this angle, who can tell me what's the next step? If you know, tell me. What is the next step? If you know it, tell me. If you know it, tell me. Thank you for the likes, all of you. So grateful. Thank you for the likes. So what's the next step after this? Okay, let me tell you now. See, I've gotten this angle already. Remember, I'm trying to get x. All right. This is an isosceles triangle. I'll say triangle TCB is isosceles. Of course, it's easy to know that, okay? It was marked already. You can see the mark here. This, and this. So the base angles are equal. The base angle, this angle and this angle, they are equal. If they are equal, I can simply say that angle CBT is equal to 180 degrees minus what? 70, because we're trying to get the base angles. Minus 70 degrees. But you have to divide it by 2. Why? You need to get the base angles, 2 base angles. And if you have removed 70 degrees from 180, share it into 2. One base angle will take 1, another base angle will take the other one. That's why we are dividing this by 2. In bracket, I will write what? Base angles of an isosceles triangle. See that? Now this is very easy now. So angle CBT is equal to 180 minus 70 is what? 110 degrees, okay? Divide this by 2, and you get, okay, I will answer that question. Somebody said, ARO796 said, how long have you been teaching? Over 10 years. This is 55 degrees. I have over a decade experience in teaching. So I have gotten this angle 55 degrees. Now, let me tell you 2 ways you can, but I want to show you, I want to do it one way, but there are 2 ways you can get this angle X. I know, see, this is 55 already. This is 55 because the base angles are equal. If this is 55, this is also 55. And can you see that there's a straight line? You see this? My markers are. This is a straight line. The sum of angles on a straight line is what? 180. So when you add x to 55 to 70, the sum will be equal to 180. But I don't want to use that method. If you want to use that method, it's fine. I want to use another method. See, if you add x to 55 to 70, they are all on a straight line. You will get 180 degrees. Who can tell me another method that I can use if I don't want to use sum of angles on a straight line? If I do not want to use sum of angles on a straight line, which other method can I use? If you can tell me, type it in the comments. I don't want to get x using sum of angles on a straight line. That is also a very good approach. All right? But I don't want to use that method. Which method can I use? Who knows it? Who knows it? Okay, in case you cannot see it, there's also an alternate segment we can use. See, do you know that this is a chord? Yes, that's a chord. And this is also a tangent. You see? I have a chord and a tangent. And the angle between them, look at the angle here, angle x, is the angle between a chord and a tangent. Can you see? We said that the angle between a chord and a tangent is equal to the angle in the alternate segment. So if this is one segment here, where you have the angle, where is the alternate segment? We draw our pretty arrow to this side, you see, to here. So it's going towards this angle. Can you now see that x is equal to what? Angle CBT. I can say, let me just do this here. X is equal to angle CBT. Why? Alternate segment. So it's not only on one side. The alternate segment can also be on this side as well. It does not always have to be. That's why I had to use this method. It does not have to be on this side. It can be on the left-hand side, not always here. It can be here as well. See, x here is equal to this angle because it's an angle in the alternate segment. You just, if you like, you can shade your, if you are very artistic and you want to test your artistic skills, shade it and then draw your arrow towards this angle. So I can say that x is equal to what? 55 degrees. That's all. So x is equal to this angle because they are angle in the alternate segment. If you understood what I just did, type yes in the comments and please let's hit the like button. Tangent chord theorem. Thank you. Tangent chord theorem. Thank you, Fatou. Thank you so much. Thank you so much. All right. If you want me to move on, type 1. If you want me to move on, type 1. Quickly, I'm going to say that our classes hold on Wednesdays, on Thursdays, not Wednesdays, Thursdays, Fridays, and Saturdays. On Thursdays, 9 p.m. West African time. On Fridays, 9 p.m. West African time. On Saturdays like this, 1 p.m., not 9 p.m., 1 p.m. West African time. So our next class would be on Thursday next week. If you missed the 2 classes, in fact, this is the 4th class already we're having. They are all in my live playlist. You just go to the live playlist. You watch all the previous videos we have done on Circle Theorems. We have looked at some theorems already. If you want to watch those videos, go there and watch those videos, okay? Our next class will be on on Thursday. Why do I keep saying Wednesday? On Thursday by 9 p.m. West Africa time. Take note. It's not the time in your country. It might be or not. Make sure you check with West Africa time, WAT. And please, if you have not joined my community, do so, all right? You can join my community. Head on to my bio. There's a link there. It take you straight to my, either you join the WhatsApp group or you join the Telegram channel. Anyone is fine. I always put my updates there. You always have access to information, latest updates for you to join my class anytime that when the class is holding, okay? And that's one. One more thing is that my paid class will be starting in November, okay? It will be starting in November. So if you register now, you are just going to pay a token. You can also check my bio. Everything is there. You just send me a message on WhatsApp. You get access to me directly, and I will give you more details on how much to pay. Of course, you are going to get a heavy discount you are paying now. This class is starting in November. We are treating class for those preparing for final exams, O levels. Those are the exams that we'll be preparing for. You don't want to miss that class. Try to be there. Okay, we're going to do one more example, and that'll be all for today. Our next class will be on Thursday next week by 9 p.m. If you missed our previous classes, they are all in the playlist, live playlist on my YouTube channel. You can go there and watch the videos. They are there, they are still there. This is the fourth lesson we're having on Circle Theorems. So one more example, and I think you might have to attempt this one by yourself. I'll give you guidance if you want, but I need you to do it by yourself. Again, this is my pretty circle. I think I'm getting better at drawing this circle already. Don't mess it up. Okay, I think that's better. Yeah. Going this way, and then I have this. Again, you know what these marks mean. This is Z. This is 48 degrees. This is Y. This is X. All right? Yeah, so we need to find, this is TA. As usual, TA is a tangent, okay? And you need to find the lettered angles. The lettered angles. What does that mean? Lettered angles. X, Y, and Z. This is Z here. So I'm going to give you 2 minutes to quickly attempt the question if you can. How long will the class be running? Okay. Are you talking about my paid class? My paid class will be running from November to April. It's 6 months of intense and intensive training, preparing for your exam. Classes we hold, there will be sessions with me. We'll be looking at past questions. You will even have access to my video course on past questions. Apart from the live classes we'll be having, I'm going to give you access to my video course that will contain video solutions to past questions. About 5 years past questions, both the objective and theory for WAEC exam. So it's loaded. It's 6 months of intern, and it's very affordable. It's about $37, I think, yeah, for SSC, for those preparing for O levels. But for BEC, that's the junior classes, I think that's about $33. So it's very affordable. If you pay now, you are paying that amount, but if you delay, it's going to increase within a short time. So if you are making payments, head on to my bio. The link is there for you to send me a message directly on WhatsApp. I'll give you access to the training. You just wait there for further instruction. But if you are paying now, you are paying just $37 for the senior classes. Junior classes is $33. Make sure you pay on time so that you enjoy the discount that is currently on. Okay? So again, please attend the question. If you have done it, let me know. Oh, I already see the answers. Some of you already dropping your answers. 48 degrees, tangent chord theorem. Okay. Who else is giving me the answer? Oh, me said 84 again. I thought you said 48. Okay, thank you. Thank you. Who else is dropping your answer? But if you join my community, you will have more details about my paid class. So you can join my community for you to have more details about the paid class. However, these free classes is still available for now. Even if I start my paid class, the free classes will not be this many, but it will still be running. But the paid class will have more attention to the student in my paid class. There will be weekly quizzes, weekly tests and assignments. You have access to video lessons, both live classes, video solutions to past questions. And you also have access to the recordings. In case you miss the live classes, there will be recordings for you to always come back to and watch at your convenience. Okay, so I'll do it quickly. I think I should do it now. Now, look at this. See, can you see that this is an isosceles triangle? You see the mark here. So I can say that solution. I can say that triangle, let me just label this. This is A, this is B, this is D. Triangle TAB is isosceles. Is isosceles, okay? Now, if that's the case, it means that Z is equal to what? 48 degrees. Yes. Why? Base angles of an isosceles triangle. Yes. Z is 48. See, look at the triangle here. These are the base angles. This angle Z and this 48 degrees, they are the base angles and they are equal. So we've gotten Z. What else do we need to get? See, the tangent can be on the top, can be at the top or at the bottom. Don't allow that to confuse you at all. This is the angle between a tangent and a chord. This angle is the same with the angle in the alternate segment. Just shade your segment and draw your arrow like this, going this way. So can you now see that X is what? Also 48 degrees. All right, and Y? Alternate what? Segment. That's it. What about Y now? Y should be easy because if this is an isosceles triangle and this is 48 degrees, I can say that Y is equal to 180 degrees minus the sum of these two angles, 48 plus 48 degrees. Y, sum of angles in a triangle. That's all. You see, it's very, very easy. So Y is equal to what? 180 degrees minus, maybe I should just do it here. Y is equal to 180 degrees minus 48 plus 48. That's what? 96. 96 degrees. So you can tell me what's 9 now? 84. Is that not 84? Yes, 84 degrees. We've gotten Y, we've gotten X, and we've gotten Z as well. So that's the answer. How many of you got it? An angle subtended by a tangent is equal to, yes, that's correct. Halumo, yes, that's correct. That's correct. That's correct. Please, after this class, head on to my bio. My community is on my bio. The Telegram channel and the WhatsApp, channel is there. Just join. You always have access to updates, more tutorials, links to my special videos. All right, I will always update the class, the WhatsApp class and the Telegram channel as well. And like I said, my paid class is starting in November. From November till, it's a one-time payment. You see, it's very affordable. 6 months from November till April next year. You have 6 months of intensive lectures from me and from other tutors, if we have provision for that. But if you pay now, you are enjoying a discount and you start having access to some benefits, some classes, some tutorials. It's good you pay now. You're enjoying discount, a heavy discount you pay now, because I will always reward those who are fast action takers. So thank you so much for being here. How many of you are here? 73 of you are in this live stream. I really appreciate your time so far. God bless all of you. We're going to have our next class on Thursday next week by 9 p.m. Then Friday, 9 p.m. And on Saturday, like this, 1 p.m. God bless you all. If you have any question before I end the live stream, you can ask in the comments. Okay, somebody said more questions. Oh, please, I will do more in the next lesson. But for now, I have to stop here. I really appreciate that you want more, which means you enjoy the lesson so much. That means so much to me. Thank you, all of you, for your time. Before you go, please hit the like button so we can get other people to have access to this live stream as well. All right, guys, I appreciate you all. Do have a wonderful day. Thank you all.